Hello everybody, today we're going to look at the standard normal distribution or Z distribution and have a look at quantiles. So this should be pretty straightforward. What we need to do is first of all understand the Z distribution. So this is a specific standard normal distribution. It is normal, but it is the easiest to understand normal distribution ever because the default mean, okay, is going to be 0 and the default standard deviation is going to be 1. Okay, so it's just a normal distribution with those two specific values for the mean and standard deviation. And what we can do is we can use this to standardize different normal distributions. So if I wanted to compare, imagine we had the math scores of you guys, look, and that was the distribution, normal, and you were centered around a mean of about 23%. And then we imagined your geography scores, and the same people, and maybe the geography scores look like that. Well, and they had a mean of 43%. Well, what we could do is we could standardize them both. We could move them, we could transform them to the standard normal distribution, the Z distribution, so we could compare how great one of your scores were, say, in math compared to that same person in geography. And that's kind of why we use it. I'll show you some examples in the next video of how we do that, though. So if we want to map, though, we can take any value that we have on our distribution. If we take away the mean and we divide by the standard deviation, we will have mapped that onto a Z distribution. So think of it here, look, okay, in terms of that math one, well, we could take 23 from every value, and that is going to move it back to having a mean of 0. And then we will squash it and control the stretch by dividing through by the standard deviation as well. That maps everything onto the Z distribution. Now we're going to introduce quantiles. Quantiles are really useful for reverse normal distribution problems. So, for example, in this problem here, we've got a population of crabs where the length of the shell X is normally distributed, and we've got a certain mean, 70 millimeters, and a standard deviation of 10 millimeters. The biologist wants to protect the population by allowing only the largest 5% of crabs to be harvested. He therefore asks the question, 95% of the crabs have lengths less than what? And what we're going to be doing here is we are working out a backwards normal distribution question. We are considering a normal distribution where we know that we have a 95% under a certain value, K. Question is, what is that value of K? And that K is a quantile. In this particular case, as it says, the 95th quantile. So that is a backwards question, and we have an inverse normal function on our calculator to help us to work out inverse normal problems. We'll look at some of those as well in the following examples.